Today's video is going to cover polynomial long division. In order to start today's lesson, I'd like you to take a look at the following do now, where I'm asking you to consider this division problem entirely in numbers and try to recall the process you would have gone through when attempting long division. I'd like you to pause the video, try the problem, and then press play and we'll go over it together. So the number that's going to go inside of our division symbol, the number being divided, is the 2,847. This is also known as our dividend, so I'm going to write that over here as well. And the number doing the dividing, the 5, otherwise known as our divisor, is going on the outside. So now I want to start with my division. So 5 cannot divide into 2, since 2 is smaller than 5, but we're going to look at the number 28. Right, move over one digit. 5 divides into 28 5 times. So I'm going to write that number 5 on the top. 5 times 5 is 25, so I'm going to write that number underneath 28. And then subtract. 28 minus 25 is 3. And then we bring down this 4, really to do it all over again. So let's just remind ourselves of the steps we just took. So we did step 1, which was to divide. Step 2 was to multiply. That's where we multiplied the 5 times 5. Step 3, we subtracted. We subtracted 28 minus 25. And then step 4, we brought down, sometimes I'll just write bring down, the 4. So we could do this again. We're going to do all 4 of these steps again. Now we're going to start with the 34. Dividing 5 into 34, that would go in evenly 6 times. Since 6 times 5 is 30, there's my multiply step. Then let's subtract. 34 minus 30 is 4, and then let's bring down that 7. So we're going to do this one more time. 47 divided by 5, it can go in as much as 9 times, since 9 times 5 is 45. Subtract. And then we cannot continue with the division, since 5 can't divide into 2. There's nothing left to bring down, so then what we call this number is our remainder. I'm going to put that on the line over here, right? It's what's left over. And the number on the top, our 569, that's going to be our quotient. That's the answer we get from division. So now we want to be able to check this without the use of the calculator. So again, not that you're going to be without your calculator, but this is a good skill to practice. It's going to be helping us in our lesson today. So division and multiplication are opposite operations. You can use one to check the other. So I'm going to take my quotient, my answer, 569, and I'm going to multiply it with my divisor. All right, so 5 times 9 is 45. 5 times 6 gives me 30, plus 4 is 34. 5 times 5 is 25, plus 3 is 28. That's not quite my dividend, the number I started with, because we have that remainder of 2 that I need to bring back. And the way I bring that back is to add it to this number. So now do I get the original number I divided into? I do. I get the 2,847. So we can check our division through multiplication, and if we have a remainder, we add it back before our final step in our check. The result of our division can be written in 2 ways. So one way you might have written this out when you did long division was you would write your quotient and then like an R2 to show that you have a remainder of 2. Another way to write it is to take your quotient and then show the adding of that remainder, but the remainder is really still stuck in the division process with the divisor of 5. So we show it with remainder over 5. So 569 plus 2 over 5, or 569 R2. We're going to kind of come back to these as we divide today with our polynomials. And then the words that we went through during this problem, our terms, are all defined for you below. Okay, so this same algorithm, the long division, divide, multiply, subtract, bring down, we're going to use the same 4 steps when we divide polynomials. The difference is that now we're going to be working with variable terms instead of just numerical terms. But we have to set it up in the same way. So let's start with number 1. We're dividing the trinomial 4x squared minus 7x minus 2 by the binomial x minus 2. So x minus 2 is my divisor. That's going to go outside of the division sign. And then 4x squared minus 7x minus 2 is my trinomial. That's going to go inside of the division. So now what I would like to do is divide. So our first step is to divide something from the divisor into the dividend. The way that this is going to work is you're always going to take just the first term of your divisor into the first term of your dividend. And this is the division that I need to do. I'm going to even write it over to the side. We're taking 4x squared and we're dividing it by x, which should leave us with just a 4x. That 4x I'm going to write right above the minus 7x because they're like terms. It's going to keep me organized as I go through this process. So we just did the first step, which is the divide step. Now we have to multiply each part of our divisor by our answer. So that means it's going to look like this. 4x is going to multiply with the x, and 4x is going to multiply with the minus 2. So 4x times x is 4x squared. I'm always going to try to line things up vertically with their like term. 4x times negative 2 is negative 8x. Okay, so we did the multiply. Now we need to subtract. But because this is a polynomial that's larger than one term, when I subtract, I want to remember that really what I have to do is distribute that minus sign. So you can do it like this, put the parentheses, or what I kind of get in the habit of doing is I just automatically change my signs. So make the 4x squared negative, make the 8x positive. There's your subtraction. The 4x squared and the minus 4x squared should cancel. Negative 7x and positive 8x would be positive 1x. And then now that we have done that step, we're going to bring down our minus 2. And now we're going to do the whole thing again. Repeat the process until you're done. First term of the divisor into the first term of the dividend. Now x minus 2 is what I'm dividing into. X is being divided by x. That should equal 1. So that 1 is going to go above the negative 2. That's my constant term. Again, now I'm going to take that 1. I'm going to multiply it with the x and the minus 2. So 1 times x is x. 1 times negative 2 is negative 2. For my subtraction step, remember, I'm just going to change their signs. And you'll notice here, everything crosses out. We have a positive and a negative x, a positive and a negative 2, which means we have no remainder. So our final answer is just our divisor, just our quotient of 4x plus 1. And if you wanted to check that, you could take 4x plus 1 and x minus 2. So the quotient, the answer, and the thing that you divided by, the divisor, if you multiplied these out, right, so this will be our little check here. 4x times x is 4x squared. 4x times negative 2 is negative 8x. 1 times x is x. 1 times negative 2 is negative 2. Combine like terms to get negative 7x in the middle. And then I have what I started with that I was dividing into. So my check worked out. Okay, let's try another one. Sometimes it'll just be simply set up for you as a fraction. Now, if you tried from lesson 1, where we were able to factor and simplify, that's another way to divide polynomials. But if you look at this example, what I'm not able to do is factor, because if I did 2 times 20, I ask myself what multiplies to 40 and adds to 15, I'm not going to be able to find two values that will do that. So what am I left with doing? Taking my x plus 6 and dividing it into my 2x squared plus 15x plus 20. If you want to, you could pause the video and take a moment to try the 4 steps and then press play, and we're going to go over it. So I'm going to take 2x squared and divide it by x. Again, it's always the first term in your divisor dividing into the first term in your dividend. So if I take 2x squared and divide it by x, I'm going to get 2x. And I'm going to write that above the 15x since they are like terms vertically. Now I'm going to multiply, distribute my 2x to the x plus 6, which would be 2x times x, which is 2x squared. You should always get that first term to be the same as the one above it. And then 2x times 6 is 12x. Just give myself a little reminder here. So we did the division, we multiplied, now we're ready to subtract. I'm going to change this to a minus, change this to a minus. So the first two terms should always cancel. The next two terms, 15x minus 12x, would be 3x. And then I'm going to bring down the 20. So I subtracted, now we're going to bring down. Okay, let's repeat the process. 3x is being divided by x to give us 3. So that plus 3 is going to go above the 20. Now we're going to multiply. Remember, you're always going to distribute that term from your answer to everything in the divisor. 3 times x is 3x. 3 times 6 is 18. And then for the subtraction step, change both the signs. All right, so we divided, we multiplied, now we're subtracting. 20 minus 18 is 2. Nothing left to bring down, so this is our remainder. So unlike number 1, where our answer was just our quotient, here, one way to write our answer is 2x plus 3. Actually, I think I left you room for this. So let's come over here. The result of this division can be written in 2 ways. So 2x plus 3 R2, remainder 2, or 2x plus 3 plus our remainder divided by the divisor. This is often called quotient remainder form, the second way that we're doing this, and sometimes the problem will ask you to write it this way and be specific. If it doesn't, then either way is fine. Okay, let's try one last problem together. So if you haven't taken a chance to pause the video and try one on your own, now would be the time. Just take a moment. I do see that the directions now state what I was saying earlier. So quotient remainder form just means that when you get your answer, you want to write it in this second form, not the first form with the R2. So if you'd like, give it a try, pause the video, and then join again, and we'll go over it. All right, so I'm going to get myself set up. They're telling me to take f of x, right, my first function, and it's being divided by g of x, which is my second function here. So if you think about first, it would look like this, 3x squared plus 7x minus 20 over x minus 2. They're kind of hinting, right, that there's a remainder since they're telling us to write it in quotient remainder form. Can you try to factor and see if you can reduce it? That's always a nice thought, but if we're being told there's a remainder, that's what we're going to need to do, the long division, not just the simplifying with factoring. So let's take a look. If I take my x minus 2, which is my divisor, into the 3x squared plus 7x minus 20, and long division will work for any division of polynomials, whereas The factoring and the simplifying for division will only work if the expression is factorable. So long division is a process that will always work for any polynomial division question. Okay, so 3x squared, we're going to start by dividing that by x. 3x squared divided by x gives us 3x. So let's write that up here above the 7x. Now let's multiply 3x times x would give me 3x squared, 3x times negative 2, negative 6x. So we multiplied, we divided, then we multiplied. Now we're about to subtract and then bring down. So we're going to subtract, change the signs. First two terms should cancel. 7x plus 6x is 13x. Bring down the negative 20. And then repeat the process again. 13x is being divided by x. Again, you don't have to write the division off to the side unless that helps you. That 13 is going to go above my constant of negative 20. Again, I'm just lining things up vertically. It also helps you know when you're done. Now that I know there's no more room in my quotient, this will be the last time I go through this process. I'm going to multiply the 13 to the x and the 13 to the minus 2. So 13 times x is 13x. 13 times negative 2 is negative 26. Now I'm going to subtract by changing the signs. I'm going to cross out the first two. They should always be opposites. Negative 20 plus 26 is going to give me 6. There's nothing left to bring down. That's my remainder. And remember, they told us to write it in this format, which is really telling you the q of x is the quotient. So let's just get some colors here. So q of x being the quotient, that's what we got as our answer. R of x is the remainder. Well, we just got that with our 6. And then let's see, get another color here. G of x, they told you originally g of x, oh, I guess I had a color for that. G of x was our denominator, our divisor, our x minus 2. So let's see if we can bring that all together. So the q of x, the quotient, is 3x plus 13, plus r of x is our remainder, that's the 6, and then g of x, x minus 2. This would be our quotient remainder form and our final answer. And how can we check this? You can always check by taking your quotient, multiplying it with your divisor, and then add back your remainder. So let's do that. So the quotient was 3x plus 13. The divisor was x minus 2. And then so I don't forget at some point I'll need to add back in that remainder of 6. So 3x times x is 3x squared. 3x times negative 2 is negative 6x. 13 times x is 13x. 13 times negative 2 is negative 26. Don't forget the remainder of 6. Let's combine like terms to get 7x in the middle and negative 20 as our constant. And this matches our original dividend. So now what I'd like you to do is try the practice questions. There are QR codes you can scan to check them, or they will appear, the answer key with the rest of the notes that we'll post on Canvas at 3:31 today.